The objective today is to be able to add and subtract radicals. So what are some prerequisite skills that you might need for this? Is obviously know how to take a square root of a number and to be able to do some square root examples like the following right here. We're going to leave out the variables, but square root of 75, square root of 48, square root of 150. You should be able to break these down really simple. If you need to, practice these really quick to make sure you're refreshed on these skills. And here would be your answer key. If you forgot how to do this, this is something you're going to need to know how to do on the more complicated examples today. Is square root of 75, you start thinking of like a perfect square that goes into that. And also square root of 48, you think of the largest perfect square to go into it. What I usually do is I take half the number and I look for a perfect square below. And for square root of 75, I have square root of 25 times the square root of 3. And for 48, I have square root of 16 times 3. Somebody might do something like 4 times 12, but that can still be simplified. So always make sure this is the largest square root, and you should be getting like 5 square root of 3 on this one, and ironically, you're going to get a 4 square root of 3 on this. So taking a look at these, refresh these before we go on to like the second example if you need a little bit more practice on examples like this. So what we're going to do today is we're going to add and subtract radicals. What you're going to have to be able to do is to think about this. This isn't like terms when you learned in probably in middle school, like example like this one, 5x, 8x, and 2y. Well, the only ones that are in common are 5x and 8x, the like terms, so you can combine those. You're going to think of that the same idea right here with the radicals is you want to get the same thing underneath the radical in order that you can add them. Here's an example I copied off the web. Notice it's both radical 5, that's simplified, and 3 plus 4 is 7. And I'll write this out for you. You can probably do it a little bit quicker in your head, but I would rather show you more steps than not enough. Sometimes you are going to get unlike radicals, and you're just going to have to leave it. So this individual simplified this one with the square root of 2 on both of these, and that's, I'm kind of curious. How did they get to 28? Okay. So they even made a mistake on this one, but I guess the whole idea is to notice that the 4 radical 2 and the 10 radical 3 are unlike radicals. So I'm surprised that they actually made a mistake and have it up there. So what we're going to have to do today is add and subtract, and think of that front number as your coefficient. As long as you have the radical, you're going to add those together. And if not, then you're going to have to simplify. Of course, we're going to lead you into ones that can be simplified. So I'm going to start you off with the easiest ones possible right here. If you look at this one, 5 radical 10 and 8 radical 10. Thinking about this one, I want to say that these are like radicals right here. Radical 10 can't be simplified. And I think 5 plus 8 is 13. So that's all I got to do is just add those numbers together and keep the 10. And that's simple. So these are the real easy ones that should go quick. Here's one that if I would put this on a quiz, some kids might get wrong. They might forget that this is actually a 1 in front right here. So all you got to do is add, yep, you got it, 7, 11. 7 radical 11 on this one right here. This also works for subtraction. As long as these are common, these are the real quick ones. You're probably getting the answer quicker than I'm writing it down. Common radical is 7. And 14 minus 8 is a negative 4. Okay. Last one before we go to another example. We got the radical 5s. Try it in your head really quick and see if you can get it quicker than I write it down. And you should get the radical 5 since that's a common denominator. Or not common denominator, I apologize, common radical. And negative 4 and negative 8 gives you a negative 12. Okay, so these are the real easy ones, examples that if you ever get confused, think of it like 6x plus 1x, and that would give you 7x. Well, instead of having 7x, we're going to have the radicals. So these are the simple ones. Let's start working into some that I didn't mind doing as a student. Like you try these two. Maybe pause it for a second. This is what you should have gotten. You should have gotten 14 radical 2 and negative 7 radical 2 because you've got your common radicals right there. And then you just add, on this example, your 1 and your 13. That's how you get 14. And this one, you're going to take 5. Don't forget that minus sign. Minus 12. That's how you get a negative 7. So these are the easy ones. Let's move into the other ones that's going to require basically a couple of steps on it. You're going to have to do some simplification. So this one right here, 5 radical 3 minus radical 12. If you're the type of student that can write this down, it would be great. Kind of give you a visual of what's going on right here. So first thing is I've got a radical 3 right here. Here's a hint. When you're starting off with some basic easy examples, the other one's probably going to have a radical 3. How do I get a radical 3 out of this? Well, the first one right here is 5 radical 3. That's the obvious. Let's simplify as much as possible. You got to start thinking of what's that largest perfect square that goes into 12, and it's 4. So I'm thinking of the square root of 4 times the square root of 3. 4 times 3 is 12. 4 happens to be a perfect square. So what I'm going to do is I'm going to simplify this. And notice all I did right here is I took the square root of 4, which is 2. And at this point, these are my coefficients, 5, and don't forget the minus sign, 2. Last time I checked, 5 minus 2 is 3. So you've got 3 radical 3 as your answer. All right, let me try another one right here. Doesn't hurt if you try this as an example real quick, is you start thinking about this in your head of what's the radical going to be. And I hope it's bring you into the direction of a radical 5. How am I going to get a radical 5 out of this one? You realize that the radical 20 needs to be simplified. So what I did is I took half of 20, and that's 10. That's not a perfect square. 9 is not a perfect square that goes into 20, but 4 is. So I've kind of break this down on the inside, and I've got radical 4 times radical 5. So I kind of keep that 8 on the outside so I don't forget about it. And then I take the square root of 4, that is 2. And then now I'm going to simplify it a little bit, and then I will start combining like terms. So where did I get the 2? I got that from square root of 4. And how did I get the 16? I did 8 times 2 right here. And that would give me the 16 here. So at this point, I just got to add these together. And I want to say 16 plus 6 is 22. And you keep the radical 5, and there's your answer. So a couple of these examples should not be too difficult for you. You might want to try an example like this, see how you're doing. I'll give you some independent practice after that one. If you've tried it, I think I have the answer worked out on the next page. Yes, I do. So on this one right here, the radical 28 needs to be simplified. What did I do? Is I kept that 3 on the outside. And this is another way of thinking of the 28. I took the square root of 4. That's my largest perfect square in there. That is the 2. 3 times 2 gave me the 6. And what did I do? I went 4 plus 6. Okay. I have one last example. I apologize I didn't show it to you earlier. It's 5 radical 18 and 7 radical 32. So this is probably the hardest one of all of them because you have to simplify both of them. And like I said, all I do is I take the half of these radicals and see if I can break it down. See if you get an answer on this one. Because this is what I came up with. Luckily, half 18 is 9. And so that's a perfect square. Half of 32 is 16. Okay, so this one wasn't too bad. All I did is I took the square root of 9 is 3. Square root of 16 is 4. And then I just multiply these numbers on the outside. And that's how I came up with the 15 right here and the 28. And I got to pay attention to that little sign right here because it's minus. And 15 minus 28 is a negative 13. Why can I combine them? Because you got the same radicals. So hopefully this was helpful to you. Give you some practice on examples like this and reach out to me if you have any questions.